All right, mathletes, here we are looking at congruent triangles. So we say two triangles are congruent if they are identical in every respect except for the position. The triangles have the same shape and size. So we consider triangles to be congruent. Remember, we can have them rotated, reflected, or translated, and they can have that different orientation, but we need to make sure that they all have sides that are congruent. So notice all three sides are congruent and three angles are all congruent. So how do we say that? Well, we say that triangle A, so notice A is labeled with a dot here. So that dot, that angle is congruent to X, so X needs to line up first, so we know it's congruent to that. So B is the angle here. That's our X angle. So then if we put B here, the X angle over here is Y. So Y goes there. And Z and C are congruent because they are the screen angle or theta there. And those parts line up. So we read this as triangle ABC, and that symbol is the symbol for congruence. So notice it looks much like our equal sign, but when we're dealing with shapes and objects, typically, and they're not numerical values, we use that symbol, which is an equal sign, and a little wavy line up top. So in our investigation in class, we noticed a couple types of triangles where we didn't always get the same side. The examples of that were the angle, angle, angle. So notice we could get a smaller triangle with the three same angles, and we could get a larger one with those same three angles. So angle, 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 triangles with those three parts aren't necessarily congruent. They could be, but not necessarily. Okay? And the second one that we dealt with were ones that were S, S, A, where side-side angle could produce two different types of triangles. So we're going to say that side-side angle is also not enough to prove triangles congruent. Again, we know we could write this ASS. We know that's a bad word. Also a bad word to prove triangles congruent. So what is enough information to prove triangles congruent? Well, they are side, 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 three sides. Okay, 1, 2, 3. Okay, is enough to prove triangles congruent. Two sides and occluded angle. So that angle is in between the two sides that we know is congruent here, that one to that one, and this side to this side. So that's what we call a side angle side congruence for triangles. Okay. The other one is our angle angle side. Okay. Or we call this more like AAS. And notice that it's a angle, angle, and then a side. So the two angles are adjacent to each other. So here it'd be angle, angle, side. And if we have that information in that order around the triangle, we can say that we have congruent triangles. Okay. The third and last one is dealing with hypotenuses. So we're dealing with right triangles. So we call this the right triangle hypotenuse side theorem. Or sometimes some textbooks will call it the HL theorem for a hypotenuse leg. So you'll see that, yes, we have an angle being 90 degrees, a side length being the same, and our hypotenuse being the same. So that'll be enough to prove triangles congruent. So how can we do it? Let's look at an example here. So in example 1, okay, we want to determine if these triangles are congruent. We can see that we have 5 congruent to 5, we have 4 congruent to 4, and we have 6 congruent to 6. So by side, 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 those two triangles are congruent. In example B here, we have a right angle, we have a hypotenuse that is congruent, and then we have a side congruent to a side. So by RHS, right triangles, hypotenuse, side, we know those two triangles are congruent, even if they are rotated around. Okay. For part C, when we look at, okay, notice we have an angle, and a side, okay, and this angle, and a side, but notice the side and the angles are not positioned in the same spot. We could deduce and decide that this angle here is 60 degrees. We can decide that this angle here is 60 degrees. But notice the side that we know on this triangle is between 50 and 60 degrees. The triangle over here, the side we know, is between 60 and 70 degrees. So this is not congruent triangles because we don't have a theorem that proves those triangles congruent because their parts aren't the same. Okay, so there's an overview of proofs of triangles, congruent triangles. Please highlight any questions you might have and bring them to class tomorrow.